Do you feel the vibes?
So, when the terminal side of an angle lies on one of the axes, it is called a quadrantal angle. So, for example, if the terminal side is here, if the initial side is this, okay? And if I want to draw a 0-degree angle, well, that's pretty much the 0-degree angle, right? Now, if that's the initial side, and if I wanted to draw a 90-degree angle, right, that's 90 degrees. The terminal side lies on the y-axis, so that would be 90 degrees. If I wanted to draw a 180-degree angle, the terminal side lies on this side of the x-axis, 180 degrees, and this will be 270 degrees. 360 degrees again will lie on the positive x-axis. Now, those angles are called quadrantal angles, either 0, 90, 180, 270, and 360. Now, in radian, those will be 0 radian, and then pi over 2. So 0 radian, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So 0, 90, 180, 270, 360, or 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. Now, let's put it all together. And what we are going to do is we are going to label this unit circle in degrees first, then in radian. Okay, so let's just talk about the first quadrant. This is 0 degrees. And then if I go up 30 degrees, that's 30 degrees. I have 45 degrees, 60 degrees, and 90 degrees. So these angles, so if you remember, the special triangles are 30, 60, 90, or 45, 45, 90. These angles, 30, 60, 90, 45, are the special angles. Those are the ones that form the special triangles. Now, their equivalents in all 4 quadrants are also significant and important. So, if you look at this one, right, that's 30 degrees up from the x-axis. Okay, now if you go to quadrant 2, 30 degrees up from the x-axis, that's this one. So the x-axis is 180 degrees, right? 30 degrees up from that will be 150. Okay, now this one, 30 degrees down from that will be 210 degrees. Lastly, this one here, this is also 30 degrees away from the x-axis. It'll be 330 degrees because 30 more would give you 360. So do you see how these 4 are all vertically 30 degrees away from the x-axis? So those are 30 degrees, 150, 210, 330. Now, let's go over to the 60-degree one, this one. This is 60 degrees from the x-axis. Here, 60 degrees up from the 180 is how much? 120. Never compare to the y-axis. Here, 60 degrees down from the 180, 240. 60 degrees before the 360, how much is that? How much? 300. So it's 360 here, so this will be 300. Now let's do the 45-degree equivalent, this one. So this is 45 degrees from the x-axis. Here, 45 degrees from the 180 will be what? 135 degrees. This one will be 225 degrees. And 315 degrees. So those are the special angles. Now notice the 45 degree equivalents all end in a 5. Okay? And please, please, please never compare to a vertical line. Okay? It's all about the x-axis. Everything is in reference to the x-axis. Okay. In degrees, we have 90 degrees for the quadrantal angle, 180, 270, and then finally 360. So now we're going to do the radian equivalents. Okay, so the purple ones, the 30 degrees. So 30 is the same as what in radian? Remember, 30 is 180 divided by 6, right? That gets you 30. So that's the same as what over 6? Pi over 6. So this will be pi over 6. And remember what I said? It's like a clock. Okay? So you have to get all of the over 6s that don't cancel. So pi over 6. This is 1 pi over 6. 2 pi over 6. 3 pi over 6. 3 pi over 6 is here. 4 pi over 6. 5 pi over 6 is the first one that doesn't cancel. So this is 5 pi over 6. What's the next one that doesn't cancel? 7 pi over 6. And the next one? 11 pi over 6. Okay? Okay, now let's do the pi over 3s. Those are the 60 degrees. Pi over 3s. Okay? 1 pi over 3. What's the next one that doesn't cancel? 2 pi over 3. What's the next one that doesn't cancel? 4 pi over 3. And then 5 pi over 3. Okay? Now let's do the pi over 4s. Pi over 4. 3 pi over 4. 5 pi over 4, 7 pi over 4. Those are the ones. Okay. All right. So the expectation is that you just know, okay, pi just by heart. Pi over 6, 5 pi over 6, 7 pi over 6, 11 over pi over 6. In the beginning, it takes a little bit, right? But it's really not that complicated because you're like, okay, 2 pi over 6, no, the 2 and the 6 reduce. 3 reduces, 4 reduces, 5 doesn't reduce, 7 doesn't reduce, 9 reduces, 11 doesn't reduce, okay? Same with the pi over 3s. Pi over 3, 2 pi over 3, 4 pi over 3, 7 pi over, 5 pi over 3. You have to know all of these, you know, rather efficiently. Okay, yeah.
For the 225.
Hey, can I ask you to open those 2 blinds? Yeah, go ahead.
225 degrees. Is that 5 pi over 9 or 5 pi over
4. Those are all of the 4s. Yeah, these are all the 4s.
I thought it was 8. It's in the middle of 4 over 8.
Yeah, 5 pi over 4. They're all the pi over 4. So 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4.
Is that equivalent to 5 pi over 8?
Is it?
Because it's in the middle of
5 pi over 4 and 5 pi over 8 are not the
4
same.
over 8 and 6 over 8. In the middle is 5 over 8.
No.
It's in the middle.
No, so 5 pi over 4. Okay, but listen. So 5 pi over 4, this is 5 over 4 pi. In mixed numbers, this is 1 1/4 pi. So we go 1 1/4 pi. Whoa, that's what we're going to do right now. 5 pi over 8, this is only 5/8 of a pi. 4/8 of a pi is 1/2. 5/8 of a pi will be somewhere here. Okay? So those are different. So now what we're going to do is the following. Go ahead and take out your homework that was for today. Okay, we're going to draw these. Okay? in standard position from 16 to 21. So, as a high school math teacher, all high school math teachers, we can't stand mixed numbers. Okay, it's all about improper fractions. Mixed numbers are so middle school, we can't stand them. The only place that I use mixed numbers is when graphing radian. So take a look. This one is 2 pi over 3, right? So 2 pi over 3, ooh. Okay. So here's what I want you to do. 2 pi over 3, I want you to show that here. Now, 2 pi over 3, this is like the pi over 3s, right? Anything over 3, 4, or 6 is a special angle. So 1 pi over 3, then the next one that doesn't cancel is 2 pi over 3, so it's got to be in the second quadrant. And so it looks like this. Remember the pi over 3s? That's like 60 degrees, so it's 60 degrees away from the x-axis. Okay, negative pi over 4. Negative pi over 4. I start here, now I'm, this way. Okay, show that. I need to go this way. Pi over 4, that's a quarter of a pi. Remember, each corner is half a pi. A quarter of a pi goes that way. Okay, 5 pi over 6. So again, okay, so this is the pi over 6s. 1 pi over 6, 2, 3, 4, 5 pi over 6. That's the second one that doesn't cancel. So it's got to be in the second quadrant. Okay, now 11 pi over 6. Okay, 11 pi over 6. We have in the first quadrant 1 pi over 6, 2, 3, 4, 5 pi over 6, 6, 7 pi over 6. 11 pi over 6 is the fourth one that doesn't cancel. It's got to be in the fourth quadrant. So here, in the fourth quadrant there. Okay, now, what's another way to draw 11 pi over 6? It's, okay, 12 pi over 6 would have been a full 2 pi. This is just under a 2 pi. But also, 11 pi over 6 is 11 over 6 pi. 11 over 6 is 1 and 5/6 of a pi. 1 pi is this much. 5/6 is just short of a full pi. So again, it gets you to the same place. Do you see that? Okay. 3 pi over 2. So now these are the pi over 2s. So here we go. The first quadrant, okay, so 1 pi over 2. 2 pi over 2 cancels. 3 pi over 2. So that's this one. 1.5 pi. Okay. Also, 1 pi over 2. 2 pi over 2. 1 pi over 2. 2 pi over 2. 3 pi over 2. 1 pi over 2. 2 pi over 2. 3 pi over 2. Okay. So now, negative 5 over 4 pi. 5 pi over 4. So how do the pi over 4s work? Just like, let's close our eyes and then think. Okay, 1 pi over 4. What's the next one that doesn't cancel? 3 pi over 4 and then 5 pi. So that's the third one, right? So now I got to go this way. Third one. 1 pi over 4, 3 pi over 4, 5 pi over 4. I got to go 3 quadrants over, and that's how I graph that. Okay? Fabulous. Okay, let's move on to section 3. Yeah. No. Don't switch to degrees and graph the degree version. The reason... Oh, okay. So eventually, I would rather you guys know how to graph them this way. Okay? All right. So let's move on to section 3. Okay. We're going to talk about trig functions of general angles. Okay. So suppose I have suppose I have any angle theta, right? This is the initial side. And the terminal side is this one. And this is an angle theta. All right? Now, we always create a right triangle at the theta. Okay? So now, suppose I have a point here, and the point is 3, 4. So if I draw an arrow from the origin to that point, 3, 4, I create an angle here with the x-axis, right? And if I make that into a right triangle, then what are some ways I can go from the origin to that point? One way is I can follow that diagonal arrow. I'm going to call that R for radius. That's one way to get there. Another way to get there is I go horizontally a little bit and then vertically a little bit. Okay, make sure you put your calculators away for the time being. Just turn them off, put them away, and listen to this. So how much would I need to go horizontally? 3. And how much would I need to go vertically? 4. Okay. Now, once I have the 3 and the 4 there, would I be able to figure out how big R was? Yeah, Pythagorean theorem, right? That's super easy. It would be 5 in this case. Okay. Now, with respect to theta, which one is the opposite side here? 4 is the opposite side. Which one is the adjacent side? Okay, and 5 is the hypotenuse, right? Okay, so what will be the sine of theta? 4 over 5, right? It would be 4 over 5. What would be the cosine of theta? 3 over 5. And what would be the tangent of theta? How much? 4 over 3. Okay? So, in other words, if this is the x coordinate and if this is the y coordinate, then the sine is the y coordinate over that number r, right? So the sine is y over r. What about the cosine? X over r. And what about the tangent? Y over x. Okay? So, if now I change the numbers from 3, 4 to something else, 7, 9, would you be able to do it the same exact way? Absolutely, right? So it is all dependent on the x coordinate, the y coordinate, and then r. How did we find r? Just Pythagorean theorem. So what is most important, however, is the following. That sine is associated with the y value, the vertical side. Cosine is associated with the x value, the horizontal side. This is so important, right? That the sine of theta is associated with the vertical side. The cosine of theta is associated with the horizontal side. So now, these we're going to memorize. Sine is y over r. Cosine is x over r. Tangent is y over x. And then, cosecant, secant, and cotangent, they're the reciprocals. And how do we find r? By taking the reciprocal. By using the distance formula or the Pythagorean theorem. So why don't we go ahead and do some of this? Okay, so let's do this. The terminal side of theta in standard position contains the point -3, 4. So here, this is x, this is y. Find the exact values of the 6 trigonometric functions of theta. Now, you don't have to draw this ever. Just this one time we're going to. So this is -3 and 4. Okay, I'm just going to draw it so I show you the orientation of this. Theta is always in between that terminal side and the x-axis. Always. So here I have, x and y. Okay, this is the point -3, 4. How much is r? Still 5. Okay, so sine of theta is always y over r, 4 over 5. I don't even look at the diagram. I just look at my point. Cosine of theta is -3 over 5. Tangent of theta is -4 over 3. The negative is important because, again, how do you get from the origin to that point? One way is, right, you go to the left -3 and up 4. So that negative is important. Okay, what is your question? Okay, go. Cosecant of theta is 5 over 4. Secant is -5 over 3. Cotangent, -3 over 4. Okay? You don't have to draw the diagram, ever. Okay. Now, yep. Yeah. No, you have to put the negative. You have to put the negative. Okay. So, reference angle. This is a brand new thing you've never seen before. A reference angle is an acute angle formed by the terminal side of an angle and the x-axis. So this should be by the terminal side of an angle and the x-axis. The value of the reference angle must always be between 0 and 90 or 0 and pi over 2. Now, take a look here. Suppose you have an angle theta in quadrant 1. This is the terminal side. The angle between the terminal side and the x-axis, that's your reference angle. So in this case, if you have an angle of 50 degrees, 50 degrees is your reference angle. Okay, yeah.
Can the reference angle be 90?
No, 0 and 90. Okay, so take a look at this one for a minute. This is theta. Now suppose theta is 120 degrees. Look at this. The reference angle has to be in between the terminal side and the x-axis. Now I go a little bit further and I say between the terminal side and the nearest x-axis. Because from here you can go to the axis to the left or to the right, right? So you have to go to the nearest x-axis. So if this is 120 degrees, how much is that angle over there? How much? You're sure? Oh yeah, it is 60. So we call it theta prime. That accent mark is called prime. Okay, so theta prime is equal to 180 minus 120, 60 degrees. Okay, suppose it's in quadrant 3. Suppose you have an angle that is 200 degrees. Theta prime is this one over there. Okay, so how much would that be? 20 degrees, right? Because it's 200, the whole thing is 200, so it'll be 200 minus 180, 20 degrees. I don't want you to memorize how to find these. I want you to like reason through them. And then here, suppose you have an angle of, 310 degrees. Where is the reference angle? It's this one right here. So theta prime will be how much? If it's 310 degrees, 50 degrees. Fabulous. Okay. So sketch each angle and give reference angles in degrees. So let's go ahead and do that. 300 degrees. Okay, initial side, 300, right there. This is theta prime. So we say, it's 330 degrees. Theta prime is how many? 30 degrees, right? Because it's 330 and then just 30 more. Okay, now let's do negative 800 degrees. Okay, here we go. Initial side. Okay, negative 360, right? Or how many? Okay, so if I add 360, is it enough? No, I add 360 again. So one more time, and then how much more do I still have to go? 80. Okay, so first of all, where is theta prime? This is theta prime. In between the terminal side and the x-axis. How many degrees is that? You just said it. 80 degrees. So theta prime is 80 degrees. It's not negative 80, it's 80. It is always an acute angle between 0 and 90. All right? Fabulous. Okay. Believe it or not, it is a million times easier in radian. Okay? Because in radian measure, the reference angle has the form pi over a, where a is the denominator of the reduced special angle. So for example, 4 pi over 3, is that a reduced fraction? Okay, reference angle is pi over 3. Pi over the denominator. That's it. 10 pi over 8, is that reduced? No. Reduce it to what? 5 pi over 4. So the reference angle is pi over 4. Okay? Okay, negative 35 over, what is this? Sketch the angle, then find its reference angle. Okay, first we reduce. So this is negative 7 pi over 6. No, 5 pi over 6. Whoopsies. Okay? So what's the reference angle? Pi over 6. Okay, let's draw this. So here we go. Initial side, negative 5 pi over 6. Here. Okay? Negative 5 pi over 6. Remember, 5 pi over 6 is just under a full pi. So we go almost 2 quadrants. Yeah.
How is 5 pi over 4 equal to pi over 4?
5 pi over 4 is not equal to 5. That's why there is not an equal sign there. The reference angle for it is 5 pi over 4. Is pi over 4. That's why I haven't put an equal sign, right? I write these myself, and my math symbols are not to be played with. Yeah. He said, why is 5 pi over 4 equal to pi over 4? I said, it's not. The reference angle of 5 pi over 4 is pi over 4. You always take pi over the denominator. It's the angle. So 5 pi over 4 looks like this. 5 pi over 4 looks like that. Okay? The reference angle is this. It has an... It's pi over 4. Okay. How far you are from the x-axis, and it's pi over 4. Okay, so 13 pi over 3. What is theta prime? Is this a reduced angle? What's theta prime? Pi over 3. Okay, let's graph this one. 13 over 3 is 4 1/3 pi. Is that right? Okay. So, first let's do the 4 pi. Start here. 2 pi, 4 pi. You with me? Now I need to go how much more? 1/3 of a pi. Let me ask you this. Is 1/3 more or less than a half? Less than a half, so I'm right over there. Okay? Do you see how that works? Okay, whatever you missed, you're going to have to catch on the screencast. Yeah, because we need everybody. I know, it was a bad time to miss. Okay, so, yes? Good. Okay. For each angle, find the corresponding reference angle in degrees and radian and state the quadrant in which the angle is located. Okay, here we go. 500 degrees. So 500 minus 360, what is it these days? 140. So I start here, 360, and I got to go another 140. We are in quadrant 2. What is the reference angle? 40 degrees. Right? Because I went a net of 140, so this is 40 degrees. 360. Then I had to go another 140 in order for it to be 500. Then I'm left with 40. Okay, Negative 2 pi over 3. What's the reference angle? Pi over 3. You see how much easier it is? No thinking involved, right? Like no math involved. So now, okay, I start here. Negative 2 pi over 3. So that's 2/3 of a pi. Okay? It's more than a half, but not a full. So right there, okay, which quadrant? 3. Okay, and okay, so maybe because it is the pi over 3, it would be, tilted, further to the bottom, but who cares, okay? Like for the time being, I'm not that particular. Okay, so why are we doing all this? Because in lesson 1, we're like, okay, how do you find the sine of 30 degrees? And we're like, oh my God, let me draw a special right triangle. Sine of 30 is opposite of hypotenuse. What? Root 3 over 2, root 3 over 2. Okay, fine. But how many times are you going to come across just 30 degrees? Very little. The point is, right, if you have any angle thrown at you, 17 pi over 6, what's the cosine of it? You have to be able to find it, okay? That's where we're getting at. For us to be able to do that, we need to know 2 things. A, what's the reference angle? B, what quadrant is it in? Hence this, okay? This is why I had to redo the entire package because the book doesn't go through it like this, okay? And it's all confusing in the book. Okay, so to evaluate trig functions, actually, okay, find the reference angle, and then evaluate the trig function for the reference angle. Then we have to determine the sine. But this time it's the SIGN sign, not the sine cosine sign. Okay? Okay. So, okay. All right. Suppose an angle is in quadrant 1. Right? What did we say the sine was equivalent to? The vertical or the horizontal? The vertical, the y. What did we say the cosine was equivalent to? The x. And then the tangent was related to the y and the x, correct? Okay. So sine is associated with the y. Now, if you are in the first quadrant, are you above or below the x-axis? Above. Above. Sine is associated with the y, right? If you're above the x-axis, what's y? Positive or negative? Positive. So if you're here, the sine of your angle is going to be positive. If you're here, what's the sine of your angle going to be? Positive, because it's associated with the y. If you're here, what's the sine of your angle going to be? Negative, and here? Negative. Fabulous. Okay. So now, if you're in the first quadrant, what's the cosine going to be? Positive or negative? Positive. Here? Negative. Okay. Okay? Okay. So there is actually a mnemonic, but you guys won't need that anymore. The mnemonic is all students, it doesn't, these things, they don't have to be correct statements. They just have to work. All students take calculus. So we look at ASTC. All students take calculus. Now, if you go here, all students take calculus. So in this quadrant, they're all positive. Sine, cosine, tangent, everything's positive. In this quadrant, sine is positive. Cosine and tangent are negative. Here, tangent is positive. Cosine and sine are negative. Cosine is positive. Sine and tangent are negative. Okay? All right, let's just do an example here. Okay, let's do an example. Okay, cosine of 240. What was step 1? Find the reference angle. So let's find the reference angle. 60. Okay, so the reference angle is 60. Because if you graph 180, because if you graph the angle, it's 60 degrees away from the x-axis. Okay. So now, if it's 60 degrees, now we have to evaluate cosine of 60. Okay. Okay, so look, if this angle here is 60, that's the reference angle, right? It was 60. Remember how a 30, 60, 90 triangle looks? It's 1, root 3, and 2. Remember that? So cosine of 60 would be adjacent over hypotenuse 1/2. Now, in that quadrant, is cosine positive or negative? Negative. So this answer will be negative 1/2. Okay? Let's do another one. Hang on, let's do another one. Let's do the bottom one, sine of 135. Let's do another degree equivalent. Okay, 135 is here. What's the reference angle? 45. Right? 45. Okay, so we need to find sine of 45. Now take a look. If this is a 45 degree angle, the 45 degree angle is here. So how does a 45, 45, 90 look? 1, 1, root 2. So what's sine of 45 going to be? 1 over root 2, which is root 2 over 2. In this quadrant, is sine positive or negative? Positive. Okay, so so all students take calculus, right? All students take calculus. So sine is positive here. So this is going to be positive root 2 over 2. It's all, and then sine, cosine, tangent. All means all of them are positive there. Everything is, okay. So 5 pi over 6. Let's draw 5 pi over 6. Which quadrant is it in? Second quadrant, because it's just under a pi. Okay? So 5 pi over 6. That's 5 pi over 6. What's the reference angle? Pi over 6. So what I need to find is cosecant of pi over 6. Now here is a question for you. Is pi over 6 the same as the 30 or the 60 angle? The 30. Oh, you guys are amazing. Okay, so 30. So if I draw a little triangle here, will this vertical side be the 1 or the root 3? 1, root 3, and 2, right? Just like a 30, 60, 90 triangle. Okay, cosecant is hypotenuse over what? Opposite, the other one. So it's 2 over 1. In that quadrant, now we have to figure out is cosecant positive or negative. Cosecant is the reciprocal of sine, so it goes with the sine. Sine is positive, so this is just going to be positive 2. Okay? All right, let's do one more. Cotangent of 7 pi over 3. Okay, where is 7 pi over 3? Right, so 7 pi over 3, it's not 30. Okay, so 7 pi over 3 is 2 and 1/3 of a pi. So 2 and 1/3 of a pi here. What's the reference angle? Pi over 3. So cotangent of pi over 3. Pi over 3 is like the 60 degree angle. So this is going to be root 3 over here, 1 and 2. Okay, cotangent is adjacent over opposite, 1 over root 3, which is root 3 over 3. Positive or negative? Positive. Okay. All are positive in the first one. All students take calculus. Okay, why don't we go on to this circle here? Let's draw the quadrantal angles and label them. So let's draw the quadrantal angles. This is a quadrantal angle here, right? 0 degrees and 0 radian. Okay. What would be the y coordinate there? 0. Okay, what would be the x coordinate? If the radius of the circle was 1, what would be the x coordinate? What if it was 5? What if it was r? R. Let's draw here. How many degrees is it there? What's and in pi over 2? Okay, so if what's the x coordinate there? 0 and r. Here it's 180 or pi, and it's negative r, comma 0. Here it's 270, 3 pi over 2. What's the coordinate? 0, negative r. So, if I wanted to find the sine of 0 degrees, now 0 degrees is at r comma 0. This is x, this is y, correct? Sine, remember, is y over r. What would it be? 0 over r, 0. Okay? Cosine is x over r, right? X is what? R over r, 1. Right? What's tangent? Y over x. 0 over r, 0. Okay? Now, cosecant is 1 over the sine. 1 over 0, what would that be? Undefined. Secant is 1 over cosine, 1 over 1. 1. Cotangent is 1 over tangent, 1 over 0. Undefined. Okay, it's kind of making sense, but not, right? Let's do the 90 degrees. 90 degrees, what's the coordinate? What's the coordinate? What did we just write down? 0 r. Okay, and how big is the radius to that point? R. Okay, so sine is y over r. What's the y value there? R over r, 1. Cosine, x over r, 0 over r, 0. Tangent, x over y, how much? 0 over r. Oh, no. No, sorry, it's y over x. Oh, boy. R over 0, undefined. Okay, and then these, what would the cosecant be? 1, secant, undefined. Cotangent, ooh, 0. Okay, let's just do the 180. Okay, 180, what's it's negative r comma 0. Yeah? Okay. Sine is y over r. 0 over r, 0. What's cosine? Negative r over r, negative 1. Tangent, 0 over negative r, 0. Cosecant, undefined. Secant, negative 1. Cotangent, undefined. We do the 270. Do not memorize anything ever. You have to learn how to do them. All you should know, which there is no need to memorize, are the coordinates. You can figure those out, right? And then you can just do them. Trust me, we're going to do so much. It's going to be like second nature, scarily second nature. All right, we'll stop here and
Press start.